Evaluate integral from 1 to 4 of 1 over quantity squared of x times quantity squared of x plus 1 squared. Okay, so I really don't know where to go with this one, but I'll start by rewriting it, and that'll give me time to think. So we have, I'll say this is x to the 1/2, and this will be x to the 1/2 plus 1 squared dx. So usually whenever I see something kind of nested like this, where you have like this x to the 1/2 plus 1 quantity squared, my thought is either you try to expand the square or you do a substitution. More often than not, I think you do substitution. I'm just going to go with that and see where it leads me. So you have x to the 1/2 plus 1. Take the derivative and you have x to the negative 1/2 times 1/2. Yep. Dx. And then the 1 just disappears because it's a constant. And you take the derivative of a constant, goes to 0. Okay. So if we rewrite this, this is 2 du is 1 over square root of x. Because x to the negative 1/2 is just 1 over the square root of x dx, and then there's an equal sign right here, and this is kind of sort of what we have here. So we'll go with this. We can do this. So I have an integral, and I'll leave off the limits of integration because they change when we do the substitution, but I don't want to find them, so I'll just switch back to x then before I put them back in. So let's see, we have 1 over u squared, and then we have a 2 du, because, nope, purple is a bad choice, green. So we have 1 over square root of x dx, 1 over square root of x dx, and then u's there, okay? So I'm going to rewrite this real quick. So we have 2 integral u to the negative 2 du. That negative 2 we can take the, use the power rule on, so it'd be 2 times u to the negative 1, then divide by negative 1. Then it'll be to 2 points, which will then give us negative 2 over u. Okay? And then we'll substitute back in x, and we get, let's see, negative 2 over u. So it'd be negative 2 over square root of x plus 1. And this is evaluated from, was it 1 to 4? 1 to 4, okay? But we can switch these limits of integration by, I should go with purple. You're right. Purple is a much better choice. Ooh, purple. By doing the negative sign. So I'll exchange the negative sign and switch the limits of integration. So we have 2 over square root of x plus 1 evaluated from 1 to 4, which will be 2 over square root of 1 plus 1 minus 2 over square root of 4 plus 1. And this will give us 2 over 2 minus 2 over 3, which equals 1 minus 2/3, which equals 1/3. That worked out reasonably well. Move this guy over here. See if, straighten slightly. There we go. And so then our answer here will be 1/3. Backtrack a little bit, see where we came from, where we're going. So we had this integral. We weren't quite sure what to do with it, but we saw that we had a nested function here. In nested functions, you generally want to try, nested means it's inside of another function, in this case, x squared. So we had a square root of x inside an x squared, and we could either try to expand that binomial, or we could try substitution, which usually if you can do substitution, you kind of want to, because it usually turns out a little bit easier. Plus, it seems to be in the title, so that's a good hint too. You won't have titles in the AP exam, but yeah, we can see it's there, where it's obvious. So we do substitution, we plug things in, and then after we take the derivative, we're like, oh, we actually have this other term here that we need to have in there, and so everything kind of sort of falls into place. Work through the problem, and you find out that the answer is 1/3. Not too bad. So this is how I do this problem. Thank you much. Go team.